Hey everybody, this is Scott. Thought I'd take a time to do another video on Ember this time, because it's been actually a couple months since I put a video out. And looking over a lot of the comments that I get, I think I had a few requests to kind of talk about testing within Ember. So testing is something that I spend honestly most of my time doing. If you've worked on large applications, you kind of see the value in testing. But it's a very broad subject, so I am going to break this out into multiple videos. So what I'm going to focus on today specifically is just unit testing, because I think that's kind of the simplest testing to kind of wrap your head around within Ember. So the kind of three sorts of tests that you're going to write within Ember are unit tests. So unit tests tend to be pretty simple, where you are testing your JavaScript directly. You're testing that a function returns some value that you expect. Given certain input, I'm going to get the same output. So anytime you have JavaScript, you can write a unit test for that. So that's what we're going to focus on today. But just to go over the others, integration tests are usually for components or helpers, things that you want to integrate onto a page. It's more, you got to think of it as, can I take this component and integrate it anywhere into my app and test that it acts the same no matter where it is. And then finally, there's acceptance tests, which is really high-level testing, where you'll test the behavior of your application. Can I go to this page and get the right results? And then if I click here, will this happen? Essentially, can all of these pieces come together and do what I want them to do? So we're going to focus on unit tests, and I'm also going to show you how we can get these tests to run in a CI suite. So when you generate a new project, just through Ember New, one of the things you'll notice you'll get is a Travis YAML file. So that's kind of what they recommend by default. There are tons of other CI tools out there, and certainly tons of examples of YAML files that you can just copy. But for the most part, this is all you're going to need. If you know you need to support different other types of browsers, or if your app's going to be running in a different directory, this is where you would go to make those changes. Since we're creating a pretty simple app, we're not going to need to update this here. But just keep that in mind. If you run into an error, if something's not installing correctly, you have some sort of dependency you're not getting, look to the Travis YAML file. So the app that I'm working on is this really simple app. I named it Let's Write Some Tests. So you can just go to my GitHub repo and pull this down. Oops. I had a similar app to this called like user test application, I think, where we just had some dummy models being returned. And that's essentially what this is, but then I expanded on it, adding a few extra fields just so that we had some meaningful tests to write. I didn't put any styling into this, so I apologize that the page is really, really ugly. But if we bring up like our network tab, for instance, here, you can see we do get some users back. So if you read through the Ember guides, you'll see a lot of recommendations for using Ember CLI Mirage. And it's a great way for writing acceptance tests if you want to stub your API, or even get your app up and running with kind of dummy API calls. The issue with Ember CLI Mirage, though, is it does intercept these network calls. So I've just created an Express server within this repo. So just npm install and then run it, and we'll get actual requests hitting our network tab. So there is no actual backend here. So here's our books endpoint, JSON API. So yeah, we're not hitting a real API. We're still just mocking this with Express. But I kind of like that, because we're still going to get the full suite of an actual AJAX requests, viewing it in the network tab, serializing that data, etc. So we have a couple routes. The books route just lists all the books that are being returned by my API. I can then go to /books and then a particular ID, and then I'll get just that particular book back. And same exact thing with users. I'll get a bunch of user information. Again, it's not styled, or user/ID, and we get some basic information here. So let's take a quick look at some of these models that I've created. So here is the user model. Now this right here is the information that is coming to me by default. So this part probably looks really familiar. I get the first name, the last name, the date of birth, email. Current savings amount would be like a number, how much they have within their savings account, and current checking amount, and maybe we could sum those together. So I've worked on a few financial apps before, and I know that in the databases, a lot of them store their numbers as integers, which means that $100 would actually show up as the number 10,000 because they include the cents. And then it's up to you to kind of serialize that. So I wrote this helper function called format money. So what it's going to do is divide it by 100 essentially. And then it also has a setter value. So what this function is doing here, it takes an attribute name. So you see here format money, current savings amount. And then essentially it returns a computed property for us. So if you've used computed properties before, you know that there are properties that will update and they'll observe changes on the things that you specify. So that's what we're doing here. And then the get function, that's what a computed property does by default. It calls the get function within the computed object and returns the result. But then you can also set a set value, and that's what do we actually update when a value gets passed to it. So in our instance, right, if we want them to say $100, they're going to type in 100, but we actually want that to show up as 10,000. So we are going to update the actual value in the back end, not in the back end, but on the actual model itself. But we're still going to return that value. We're not going to mutate what they're typing in, but for the purposes of saving our data, we're going to do it very consistent. And on this model, we also have a full name. That's a pretty basic one that you see on almost every example, just concatenates the two names. We'll write a unit test for that. And then we also have the age. So we get the date of birth back, but I want to calculate what that person's age is. It's kind of a confusing way. If you know how dates work in JavaScript, it counts from January 1st, 1970. So essentially what I do is I get the distance between now and their date birth, and I get those years, and I get the absolute of that subtracting 1970. That's going to give me the age. And we'll show you how we can test that, and then also how we can stub that so our tests consistently pass. And then we have a convenience method here too, a Boolean of is over 18, and that just checks whether or not the person is over 18. The next model that we have is really, really simple. It's just books. But you'll notice here I have this custom transform. So kind of two different approaches to the same problem. Here I wrote a custom computed property, and I certainly could have copied this over and just used it in the book model. It probably would have made sense, but just to kind of demonstrate how we can do this. So again, price is going to come as a full number to me, including the cents, and I want to divide it by 100. So I created what's called a transform. So if you've ever used attributes within Ember data, string, number, date, those are what are called transforms. That just tells Ember data how it needs to treat that data, what is and is not valid, how it's supposed to serialize it. So if you go to your transforms folder, you can actually add your own. So it has two things, a deserialize and a serialize method. Deserialize, I'm just dividing it by 100. Serialize, I'm doing the opposite. I'm multiplying it by 100, and I'm going to drop any decimal points that might happen to be there by using math.floor. We're not going to be updating data live in this application. There's no inputs, but that's how you would do that. So again, this is kind of solving the same problem that we were doing here, just kind of two different ways to do it, and I'm going to show you how we can test that either way. So now that this application is, it's up and running, it's doing what you want to do, you might be wondering, all right, do I need to actually write tests? If you've never written tests before, it can be kind of confusing why they add value. But if you've worked on an application where there's a lot of different developers contributing to one code base, it becomes really obvious that tests just tell people when things are broken. If somebody comes in here and deletes the full name computed property because they don't use it or they never seen it used, but you actually do use it in some function that they're not aware of, a failing test is going to tell them, no, like this is important. You broke functionality because you removed that. Please put it back. And yeah, it just kind of tests that things are, in fact, working as expected. The next big thing is regressions. So if you've shipped apps, you're going to run into bugs, a user doing something that they shouldn't do. And once you debug that and you know what the root cause is, you should write a test to that effect. Essentially, a test that failed before, but after your changes, passes. So that protects you again against regressions, so that bug doesn't ever come back. So that's kind of my sale pitch on writing tests. You can go as in-depth as you want. There's lots of tools out there that talk about code coverage and how many tests you need to write. Use your own discretion. So I'm not going to be a huge stickler for that. So in Ember, how do we actually run our tests? We can do that a few different ways. Our app's running here on localhost 4200. We did that by doing Ember.js. So if I go to localhost 4200/tests, it's going to run all my tests in QUnit. So QUnit is the test suite that Ember ships with by default. It's integrated very tightly into kind of the Ember ecosystem. So you could write tests in Jasmine or some other tool, but this is all automated for you anyway. And it uses ESLint. JSLint used to be the default that shipped with Ember. Now it's ESLint, and that just makes sure that your JavaScript essentially looks good. You can actually see here I have a failing one already, so ESLint caught something for me. I actually am trying to use a function that's not defined. It'll also tell you when you're declaring a variable or a method but then never use it. Trailing white spaces, you can set that up. You can have it check for missing semicolons, spaces after curly braces, lots of different things. And you can actually go in and set how strict you want this to be. And then within files too, you can actually tell it to ESLint to like ignore certain things. For instance, if you're using global variables, it might tell you that that variable is undefined. In that file, you can just go and specify that that is global. So let's actually go and fix this test real quick. One of the really handy things in QUnit is that we can check this thing, which is hide past tests. So now we'll only see the failures that we have. So model users, set is not defined. Model users. Where is set? Set is here. And yep, set is in fact not defined. So we will get that. That's ember.set. I'm destructuring it. This is the new module import API. So in case you were wondering what version of Ember we're on, we're using 3.0. This is the latest version as of this video. But the stuff that we cover here is going to apply for really any version of Ember later than Ember 2. Even 1.13 most likely, because we're just going to write some simple unit tests. The only exception is this module's API probably didn't exist. So rather than importing Ember and then you have ember.computed and ember.get, you can just import the things that you need as you need them. So I think it makes it a little bit easier to read. Some people disagree, but to each their own. All right, so now that test is passing. So if we go back, uncheck this, you can see all these tests here are ESLint ones. If you ever want to run a specific test, you can do that through this drop down right here. And we are, in fact, going to start with the user model. So I can check that, click apply, and it will run this test. And I can click here to kind of expand it. And all it's doing right now is running the boilerplate code that's created when you generate a model through Ember CLI. So let's look at unit model user test. And this is what it looks like by default. Module, unit, model, user. It runs the setup test hook. This is new in the latest version of Ember QUnit. If you're running older versions of Ember, you've probably seen this module for model, then the model name, and then it specifies that it's a unit, a model, and then I think it's another pipe, and then the name of the model. And then in here you would have your dependencies. So we don't have any here, but if you if this model used a service, for instance, you would say like service, then the name of the service that it depends on. We don't have that here, so we don't need the needs hook here. And again, that was the old way to write it. We're focusing on the new way, which is within this module. And then we have the test helper. So the first thing here is the message that shows up here. So you usually want to isolate it by behavior, right? So it calculates user information properly. So what we're going to do here is we're going to make sure that given specific inputs, we can get their full name and their age, and maybe even these fields properly. So the test is going to test multiple things, and what we're going to do is we're going to have multiple assertions here. So assert is really what the real test is. We're going to assert that one value either equals another, one value is true or false, and that's this part that we see here. It just says okay. So if I went assert okay, this is good. That's the message that we will see here. This is good. So the last parameter to all of the assert methods is an optional parameter of a string that you can kind of give it more description. I highly recommend doing that so that when a test does fail, you get a descriptive error message that says, unable to get person's age, or person is over 18, or something like that. So another thing that you're going to see here by default is that it does import the Ember run loop. This is something that in older versions of Ember did not happen. You had to import it yourself. You didn't always need to import it because you didn't always use the run loop. But the thing is that the run loop, the actions here do not run within the Ember run loop by default. So when we are updating properties, you have to wrap it in a run so that the essentially order of events happen properly. So just one of those things to keep in mind. You usually get a useful error that says, wrap async behaviors within a run. That's what it's referring to. Make sure you specify that we're going to put this in a run loop so that it runs in isolation before the rest of the test continues. So let's delete this comment, replace this with our real test, because that's what we're going to do. So here's the store in Ember data. That's how we create records. The model here, we're going to call store.createRecord. And this right here is where we can actually pass in the fields that we want for this model. So again, we're just dealing with this specific model, which is kind of like our schema. We're not actually making an AJAX request. In this test, we're not going to stub like we're making an AJAX request. We're just going to give it some values and hope that we get the right values back. So let's actually just copy all of these here. I'm going to paste them in. Cool. So first name, we'll call Bob. Last name we'll call Builder. Why not? Date of birth. Trying to remember how I stub this on the back end. Okay, yeah, just a plain old date. So I just want to make sure I'm doing it consistently. Email, I'm not going to write a test for email because we don't actually do anything with email in these. And I really don't need to write a test that asserts that this understands that email is a string. So that's one of the things to be kind of careful of. Don't write unnecessary tests and question whether you're writing tests for your app or if you're testing Ember. So unless I was doing something with email, which I'm not, I really don't need to test that Ember can take a string and understand that it is in fact a string. So we're not going to write a test for that. Current savings amount, we're going to do this, sure, random number, and checking amount, they have a ton of money. So let's delete this because that test is always going to pass, and talk about what it is that we want to test here. So assert comes from QUnit, so it's passed into this function, our anonymous function here. And assert has a bunch of different methods. So assert.ok is testing Boolean values. It's looking for a value of true. So a good example of that is person over 18. So we set a date of 1975. So that person should be over 18. So if we do model.get is over 18, we should get a passing test. And again, let's add a message here. They are over 18. And yes, they are over 18. If we changed this to 2014, fail. So when a test fails, it gives you two things, the expected and the result. So it expected it to be true, the result was false. With Boolean tests, that's usually not helpful. But if you had a test that was trying to test the value of toString, then you would actually get the two strings. They expected this and got this, and you might be able to debug it much better that way. So we'll change this back. They are in fact over 18. So to go over the other assert methods that you'll often use, the most common is probably assert.equal. Takes two parameters, value 1, value 2, and just compares them and makes sure that they are equal. The next is assert.notEqual, camel case not equal. Does the inverse, takes value 1 and value 2 and asserts that they are in fact not equal. Similar to that, you also have assert.notOK. So that will look for a value of false. If you want to make sure that something is false, you would use not okay rather than okay, and then not here. So just use not okay. Now the caveat with assert.equal, if you're comparing two objects, you're probably going to get false positives because it's not going to compare the individual values of those objects. So let's mock up an example real quick. Let person equals, we'll say their name is Bob and their occupation is builder. I don't know why I keep using that example. And then let's say we have another object here, person 2. But person 2 has the same exact values, and I want to compare whether these two things are equal. So if I do assert.equal person and person 2, it's going to tell me that it's not. It says the diff suppresses expected and actual results of an equivalent serialization, which is super confusing. But it's saying that, yeah, they look right, but they're technically not the same. They're two different objects, and that's true. These are two different objects in memory. So if I try to do assert.equal, they will in fact not be equal. And that's what the deep equal method is for. So that's actually going to go through the whole object or whole array and compare each individual one and see if they are in fact equal. So now you can see that these do pass. So if you're ever comparing objects and you want to make sure all the values within those objects are equal, that's when you would use deep equal. If you use just plain old equal, you could potentially get a false negative, like we had here, where yeah, actually these values were equal, but they were the same. There were different things in memory, so then they didn't actually they had different serializations. Or if I had done person 2 equals person, and then maybe added some activities equals running, and change this to equal, that's going to pass. Because again, now it's referring to the same object in memory. I've actually mutated person 1. So be careful of that, kind of assigning objects, hashes, and arrays. Deep equal is what you want when you're comparing all the individual values. Otherwise, use equal for simple values. Does this string equal that string? Does this number equal that number? Those are what those methods are designed for. So we got our first assertion here. We tested that the person is in fact over 18. So next, let's see if we can assert that we got the proper age back. So assert.equal, model.get. And again, this is a computed property that I've created. That's why we're testing it here. Versus, like I said before, there's no need to test the attributes, right? Because these are tested by Ember and the Ember engineers. This is something that I've written, so I should test this functionality. So if they were born in 1975, 2018 minus 1975, they should be 43. So get age is 43. Person is 43. And that passes. So that works. And because this works, we know that this works, right? There's an issue here, though, and it should be pretty obvious to anybody who's dealt with dates before, is it relies on date.now. So the issue that we run into is if this test suite is around for a while and 2019 rolls around, the person's going to be 44. Now I have a failing test, not because anything changed, but because I didn't stub something correctly. So how do you get around this? How do I make it so that my tests are always going to pass consistently because my behavior hasn't changed whatsoever? Well, you could just go in every year and update this, but that's a huge hassle, especially if you have hundreds of tests. So what we want to do is we actually want to stub something here. We're going to stub date.now, and we're just going to have it return a consistent date. So essentially what our test is saying, if this app was run on January 1st, 2018, this is what the person's age would be given the date that you gave me. So how do we do that? I want this, again, to run consistently with that date. And the way that I can do that is I can use these hooks that we set up here. So there's a hook here called hooks.beforeEach. Now in that old example that I showed you where we had module for model and then a string, then another string, and then a hash, that's where you would put this before each. So again, if you're on a version of Ember that's older than 3.0, look for this module for, and then in that hash, that's where you would put before each. And then there's another hook that we can use, and that's after each, hooks dot after each. So what do these do? Well, this is just code that's going to execute before each test, and then code that's going to execute after every test. So a test, again, encapsulates certain behavior for us, and these are things that I just want to set up in my test suite. I know that I'm going to want this for every single test, so I can put this in this before each rather than having to write it out every single time. So before each takes one thing, and that is a function that it will execute. Same with after each. Now what I want to do is stub date.now. Now the problem with this is that if I overwrite date.now, I'm going to end up overwriting it for my entire test suite, and that might not actually be the behavior that I want. So what we're going to do is we're going to say original date now. We're going to create a variable up here, and we're going to get what the original value of date.now is, right? And we're going to save it to that variable. That way, after the test, we're going to restore it. So we're going to store value of date.now. Then we're going to stub date.now to consistently return 1/1/2018. All right, so to do that, we use the object namespace within JavaScript. So if you haven't worked with objects and object prototypes before, what we want to do is we want to call object here. And if you bring up your terminal, kind of in any particular place, you can type object and take a look at what methods you have available to you. One of them is called this, get own property descriptor. And that takes two arguments. It takes the object itself, so in this case the date object, and then the property on that you want to get. So let's copy this, but we'll hit enter here, and you can see here we get a few things back. Configurable is true because we can overwrite it. Enumerable is whether it shows up in a for in loop for you. And the value, that's the actual function that gets called. When we call date.now, it returns this. So let's copy this line, and we're going to say original date.now equals that. So now that we've done that, we now want to stub this property. So let's go back to our terminal, and let me make this a bit bigger. I'm sorry if that wasn't readable before. So object.define property is a way that we can overwrite things within objects. Since it is configurable and writable true, we will be able to overwrite this. If you ever try to use this on something like Navigator and it tells you it's read-only, it's because it's not writable. So we're going to overwrite date.now, and that takes a hash just like this does, right? Value, writable, enumerable, configurable. I don't care about these other properties. I only care about the value. I only care about the function that gets called. So if I say value is a function, and in my console I'm just going to have it return foo, and I have an unexpected token. Yep, because I'm missing a curly brace. So now if I go date.now, It's going to return foo for me. So look how easy that was to just stub this. So we're going to make it return a consistent date for us. So here, and let me just break this onto multiple lines. So again, it's a little easier to read. Same with this. So value is in fact a function. ES6, we can just write it like that. And we're going to return new date 1s1/2018. So finally, so now we've done these two steps, right? We saved it, the original value, to this, and then we defined our stubbed version here. So then after our test runs, we want to restore it. And again, you want to do this because if you overwrite this, it's going to be the same for all of your tests. So if you have other tests that might rely on date.now, they could break because you overwrote it in this particular test, even though that's not the behavior you want. And we'll just set it right back to what it was. So using the same exact method, define property now, original date now. So let's save this. And you'll see it actually worked. Our test failed because the person's birth date is January 12th, and we set it to January 1st. So let's update this. The person is 42 years old. They're still over 18, which is right. But now we've stubbed this, and this test is going to pass forever because we're consistently stubbing this date. We don't have to worry about this test failing next year. Our next computed property that we have, which is the full name. We just want to make sure it concatenates the name for us. So model.get full name. And what we called it Bob Builder. And maybe I don't have an extra description here because I think it's kind of self-explanatory, but here it just says okay. And I'll put it in. We'll just say proper name. Great. So one of the other things that you can put in is assert.expect. And this is the number of tests that you expect to run. Oops, 3. Right? We have 3 assertions here. I expect there to be 3, and there are. And the reason you do this is if you ever have an assertion within a function, you want to make sure that that function isn't called a bunch of times. That's how you can write that. Or you can also write a test that just asserts that a function is in fact called. Assert.expect essentially does that for you because you're going to say, I expect only 3 assertions here, so I expect my test to run this function X amount of times. So next we can test these two here, that they actually format the currency properly. So assert.equal_model.get this, and it should be this divided by 100, so it should just be 100. And now I have another assertion here, so now I expect there to be 4, and it runs properly. So we'll do the same thing here, but for this field, current checking in sense, and it should just be this number minus some zeros. And now you see I get this failure. Expected 4 assertions, but 5 were run. Because again, I didn't update this. So again, not something you always need to have. It's a good way to kind of document your tests. We can delete it here, but again, there will be times where you want to assert that a certain number of things happen, and that's a way to do that. Now, just to make sure that the sent thing is working, let's give it an actual sent value. And that does work. Again, if I gave it a different value, you can see this is how it would return it to me. Expected this, got this. So it is really, really handy when a test does actually fail, and you can kind of compare it and just say, oh yeah, I forgot to type this. If you misspelled the person's name, it's going to compare the 2 strings, and then I'll even highlight in the diff for strings what you're missing there. So I missed that D. Oh, great. Super easy to run. So along those lines, let's write another test here because I want to play around with these values. So in this test, I'm only going to test those currency values. And because I'm doing that, again, I'm going to isolate the actual behavior here. So let's take these 2 things out. So this here is just kind of dealing with the personal information. Calculates user, we'll say users personal information properly. Now it calculates users financial information. So now I don't actually care about their name at all. And we're just going to play around with these two numbers. So if I go ahead and save this, you'll see now it has broken it out into two individual tests rather than one giant suite, because again, I'm isolating the behavior here. So I've tested that it does in fact serialize this stuff correctly. But now what I want to test is that I can get this amount if I update this. So if I said model.set this value here to 45732, 45323, I don't know why I said the wrong word there. So this should add, this value should now be updated with two trailing zeros. Because again, that was the behavior. This is the value including the cents, so essentially the number of pennies. And then we divided it by 100 to get this value, right? Now I'm updating that value. So now I need to add two more zeros on it because again, what I want to save is the number of pennies. So now I should be able to do assert.equal model.get. But now we're testing this one. We're doing the inverse of before. And it should be this number, but with two more zeros added on. And now we have a failure. Assertion failed. You have turned on testing mode, which disabled the run loop's auto run. You will need to wrap any code with asynchronous side effects in a run. So I mentioned this in the beginning. That's what's happening here. Because again, the run loop doesn't run in testing mode by default. So in order for us to test behavior like this, essentially changes trickling down or bubbling up, we need to say run this in isolation. So run this in a run loop. So run takes one method, which is an anonymous function, and executes that code. Let me add my semicolon here. And now you see this actually passes. So again, asynchronous behavior up. If you're updating a property, if you're calling object.set, you're probably going to have to put it in a run when you're within a unit test. And let's do the same thing here. We'll update this amount to 88. And then what we're testing is that we get 8800 back. And we do. We have 7 full tests that we've now run. All right, so I think that's enough for the model, or user model. We stubbed the date. We made sure we restored it after every test. And we talked about asynchronous behavior within the run loop. Those are the big things you're going to have to deal with within unit tests. You know, writing a test that asserts one string equals another string is pretty simple. It's when you have to deal with stubbing values or asynchronous behavior that it becomes a headache. And it's always best to kind of just break it down. If you can extract it to helper methods and then stub those helper methods, do that. Otherwise, look into whether it's a behavior of asynchronous behavior. And if it is, maybe that doesn't belong in your model JavaScript file. So I showed before that we had created this transform called $.sense. So let's write a unit test for this. It'll be very similar to what we had before. So we'll say unit $.sense. So it looks just like our other test, but we're going to say it serializes correctly. And we're going to delete that test because, again, that's just saying does this object exist, and it does, but we already knew that. So we want to test the deserialize method. The deserialize method is going to divide this by 100. So we'll say transform, or that value equals transform, which is this, that it's looked up within our application. So transform dot deserialize 1000, and then we're just going to assert dot equal that our value is equal to 10. It has in fact deserialized it correctly. You'll see we're still running this test though because we're within this module, so we can go to our drop down here, uncheck this one, and then check our transform and apply that. There we go. Deserialized it correctly. And we'll test the inverse too. Whoops, this is deserializes. deserializes correctly. Now we're testing that it serializes correctly. So we'll call serialize, we'll say 10.25, and we'll come back as 10.25. There we go. We created a transform and a unit test. Very, very simple. You might think, well, duh, of course that was going to work. But again, you're not testing that you were able to write some really complex JavaScript and you destructured your algorithm correctly. What you're testing is, or what you're asserting is that this behavior is important, your app depends on it, and if it breaks, something in your app's going to break. So if somebody goes in and deletes this file or changes it, this test will fail and they'll say, oh, actually it looks like somebody was depending on this, so maybe I should update that. So in terms of what takes a unit test, when you create things with Ember CLI, it will create boilerplate tests for you to kind of lean you towards writing tests a certain way. Models, for example, have unit tests. Transforms, we saw, have unit tests. Route files will have unit tests, as will controllers, utils, and services. But that doesn't mean that those are the only things that you can write unit tests for. Things like helpers and components, they will generate integration tests by default, but you can write unit tests for them. Again, you can write unit tests for anything that you have JavaScript with. As a fair warning, though, if you find yourself that you need to write unit tests for things like your components, it's probably a red flag that you need to extract some of that behavior out of your component and maybe put it in something like a util or a service. But just to show you, you can in fact generate those tests through the boilerplate here. So let's write some tests. So if you ever want to generate a test, you can say Ember generate, and then the name of the module that you want -test. So in my app, I have this helper, which takes a number and changes it into a currency. It's under helpers.format currency. So here's this long regex that essentially asserts that we have the right number of digits, and then, yeah, does a lot of stuff, but if I give it 10, it's going to give me $10.00. So that, again, is, by default, it's going to be an integration test, and I'm going to cover integration tests in another video. But if I wanted to just test that function itself, I can do that through Ember generate helper test --unit. Oops, sorry, we actually need format currency. Sorry, I've completely blanked on getting the actual name of the helper, which is format currency. Ember generate helper test format currency --unit. If I didn't have the --unit, it would just generate an integration test for me. So now we can go and look at this unit format currency test. And again, looks just like all the other tests that we've had. And if we go to our test page here, we'll be able to select it from this drop down. Format currency unit helper. So helpers by default actually accept arrays as parameters, and the reason for that is helpers are meant to be used within a template, and because it doesn't know how many properties you're going to send along, it has all of the properties of that function saved within an array. So format currency 42, we actually want to assert equal that the result comes back as a string of $42. And it does. And we'll say it formats value properly. And it does. However, we actually test a few more things in this, not just that simple value. We formats 2 digits, but what about many digits? So this, it will actually add the commas in. That's what that helper is really doing. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. It many digits. It formats many digits. We save that, tests automatically update. It formats value properly. So again, even though the boilerplate, or excuse me, the default blueprints tell me I need to write an integration test for helpers, and I absolutely should, you can write your own unit tests for that. Very, very simple to set up. So the only other thing I guess I could cover with these is if you're doing something maybe like this. So this is something you'll see in a lot of applications. The model comes through, it makes a request to the back end. And then in the setup controller hook, what it does is it sets a property on the controller that is the value of the model. So by default, the controller will accept whatever comes from this function and then just call it model. A lot of times we'll do things like this because it's more convenient to call it book. It makes the templates much more easy to read, because we work with a lot of UXD designers who don't know, UXD developers who don't necessarily know Ember, but they do know how to read templates. So if they see model.name, they'll have no idea what that means, but book.name does mean something to them. So because we're gonna write stuff like that, template show, so you see I pass book, a property called book, to this component that I have. Therefore, my app is dependent on something being called book. So I should write a test for that. So let's go to unit route books show test. So what are we actually testing here? Well, I'm testing that my controller, when it's set up, will in fact have a property called book. So let's create a dummy controller here, which again is just an object, right? So let controller. So then we can call setup controller, or excuse me, route dot setup controller. So again, route here is referring to the actual object itself. So now I have access to all the functions that a route object would have access to, and I can just call them as I want. I don't have to go through the life cycle necessarily. I'm just going to assert that I get the result that I'm expecting here. So we'll call this dummy model, and a book, has a name of foo and a price of 100. So we're going to call setup controller, we're going to pass it the controller, and we're going to pass it the dummy model, because that's what setup controller accepts two parameters here, setup controller, controller, and model. Then we're going to assert dot deep equal that controller dot book. So the new property that we are creating on the controller object equals the model that we're passing it. So again, deep equal sets up book model. So deep equal is when we want to assert multiple values within an object. So we're essentially serializing it, going through and making sure everything is set up correctly. It sets up the controller, if I could spell. And now let's actually go and find that. Route books show, and it sets up the controller. Great. Now obviously I want to do this for all of my routes. I'm not going to do that now because it's just kind of rinse and repeat at this point. But again, tests aren't necessarily about testing complex behavior and showing how smart you are. It's testing that I have an app that depends on this thing, and if it breaks, my app's broken. So I should have a test to that result. So that's kind of unit testing in a nutshell. Essentially, unit tests, we're testing JavaScript functions or properties, and given certain inputs, I'm going to get the same results back. So now that I have all these changes, I'm going to create a new branch here, git checkout unit tests. And before I continue, let's go ahead and run all of our tests again. So if I remove this module, it's going to run all the tests, and they all pass. So we're green here. All my tests are written. If I wrote a new feature, I'm confident that I did it correctly and I haven't broken anything else. So let's just go ahead and add all those. Add basic unit test, and we're going to push that up to our repo. So if I come here on GitHub, I can compare this and open a pull request, which is what I'm going to do. What's in this PR? Basic unit tests. And we created this pull request. So it checks for merge conflicts, and then in GitHub you'll notice, hey, you can set up some continuous integration, and that's what Travis is. That Travis YAML file is what's going to allow us to run tests here. So let me bring this page over. So this is travis.org/profile and then my name. So you do log in through GitHub, and this just lists out all of your repositories, and you can set up Travis to run on those. It's perfectly free at travisci.org. travisci.com is the paid version. So if you have private repositories, I believe you have to pay for that. You also just get faster service if you pay for it. So when you log in, make sure you sync, because it won't have an up-to-date list of your repositories here. So all you have to do is find the application that you created and just give it that check. And that's it. So if you go back to your branch, if you added Travis after you open the PR, you'll have to close the PR and reopen it apparently. But now our test suite is going to run. So yellow indicates that Travis is running through our test suite, and when it's green, that's telling everybody, hey, this person didn't break any behavior. The app works perfectly. So again, if you're working with a large group, this is super, super helpful. Let people know that yeah, you didn't break any behavior. And then we're going to go and we kind of look at all the changes that we made. So I'm going to leave this PR open because again, this was supposed to just be for testing purposes. So you can come here and look at this PR, and you'll also be able to check out this branch if you want. So it's just the unit tests branch. Leave any comments on this, specifically if you had questions on the actual code itself. But that's kind of unit testing in a nutshell. So hopefully this video was helpful. If you have any questions, leave them in the comments. I'm going to try to cover integration tests pretty soon, and then finally application or acceptance tests, where we test our whole application, which is much more complex than unit testing. But yeah, thanks for watching.